Hello and welcome to this Aerospace Testing International and Aversan webinar. Today's webinar is called Remote and Distributed DO-178 Testing. So today we're going to have a short presentation from two experts from Aversan, Sandeep Duna and Ryan Anderson, about software testing. More specifically, we're going to be talking about running remote distributed software testing campaigns and outsourcing those. So I know the speakers have lots of great practical suggestions and best practice tips about software verification and validation. So you're all going to really find this valuable. So there's a whole hour for the session. The way it's going to run is after the presentation, we will have a short Q&A with questions hopefully submitted by you guys, the audience. Can I encourage you to submit those questions during the actual presentation? They won't appear instantly, but I will publish them for everyone to see during the actual Q&A. So before I hand over to Sandeep and Ryan, I'll just introduce them properly. So Sandeep is a principal software engineer at Aversan, and he has 17 years of experience in software engineering, including contributing to the development and testing of numerous projects in safety critical systems, like those that you'd find in aerospace, rail signaling, digital health, IT, IoT, and in medical devices. As a principal software engineer, Sandeep has influence on the direction and quality of Aversan's software development, its test efforts, and he's a major contributor to the automation and productivity toolsets. Ryan Anderson has been a member of the business development team at Aversan for more than 5 years. His responsibilities include account management, new business, proposal development, and price estimation. That's enough from me. I hope everyone finds the presentation useful. I'm sure they will do. And over to you, Ryan.
Thanks. Okay, so just to run through the agenda of what we're going to talk about. We'll do our quick introductions, which we've already done, and then we're really going to dive into covering the challenges that we think ourselves and many of you might face in running remote and distributed DO-178 test campaigns. And we're going to frame that really in the context of a case study of a project that we ran in 2021. So we'll go through the challenges kind of in the chronology of how a project is normally run. So we'll start with the planning phase, then move on to reporting, monitoring, and then finally execution. Then we'll do a quick recap of the best practices that we covered, and then we'll move into the Q&A. So a bit about us. I'm Ryan Anderson. This is Sandeep. We already had a great introduction from ATI, so I won't dive into this. But you will be able to get the slides afterwards, and our contact info is in here, and I encourage any of you to contact us if you have any questions. So just to start off a little bit about Aversan. So we're a global engineering firm with about 100 employees. We're specialized in the testing and development of safety critical embedded systems. So, we've been participating in DO-178 V&V projects for about 18 years, primarily as a tier 2 to some of the major system integrators, some of our customers that you can see here. So as a company that focuses on DO-178 V&V, this is really our bread and butter, and we've learned quite a lot of best practices and tips that we want to share with you in this webinar that, have really come from the practical experience that we've had of running test campaigns. And in particular, as an outsourced company, we've been running test campaigns where we're remote and distributed, long before, the recent events drove that to be more of a requirement. So it should be very useful for you. So just to go through what I said before, so we'll go through the challenges kind of in the context of how we run the program. And Sandeep will lead you guys through that case study. So in the planning phase, we'll go through tool selection, setup, defining workflows. During execution, we'll look at training and onboarding, and more importantly, how to manage and maintain productivity and quality, as well as just some tips on how we manage test artifacts, which, especially in the context of high criticality DO-178 test campaigns is pretty important for auditability. And we'll cover how we monitor, control, and status projects. So specifically, we'll look actually at how we do metrics and KPIs. And so with that, I will hand this over to Sandeep.
Okay, thank you, Ryan, and thank you everyone for attending. So we'll start with some of the scope and background. So the project that we worked on required DO-178 testing, and the focus was on verification of numerical decision points, and there were thousands of them. The team estimates were quite large, and the customer required it to be done by another team because they were fully loaded. And they decided to outsource it to us as well as another vendor. So here's just an indication of some of the challenges and solutions. So, Aversan had a team of 11 working mostly from Ontario. There was another team in Costa Rica, and our customer lead, he was actually in London, England. And basically, the solution that was chosen was to get every tester their individual virtual machine. They had a remote desktop application installed on their machines, and they would basically VPN in and network in to their one-to-one assigned virtual machines, which had all the necessary software on them. And those virtual machines were managed and maintained by the customer. Oh, and that was important because all the IP had to stay on the customer's resources. Okay, so we'll talk a bit about the tool selection. So having a very distributed team, as I laid out, we needed a tool that catered to that. So we chose to go with Azure DevOps, and the reason we did that is because it provided basically a single solution that gave us everything we needed. The main concepts were tickets for tracking the work, as well as a repository for storing all of our configuration items, including the test artifacts and code, as well as wikis. So that way we could actually very quickly document work instructions, things we figured out, and share that among the team. We also relied heavily upon Microsoft Teams. That became our day-to-day communication tool.
Yeah, and I just want to point out too with the virtual machine solution, that's actually been very, very helpful. So if you haven't tried using that with some of your teams, setting up VMs for the team members to have access, we find it very, very helpful, and it lets us onboard resources very quickly. And especially with remote team members, when they're VMing, they can bring their own device. Since everything's contained in that VM, it makes things very, very easy. People don't even need to come into our office when they get onboarded; they just get the VM credentials. So that's actually a really good solution we found in this project that we're trying to implement on other projects as well.
Yeah, when COVID hit, I actually got back from vacation, and I had to quarantine, and that time was voluntary, so I couldn't even go into the office to get my laptop. But with this project, I just downloaded a client and I VPN'd in from my own personal computer, and it made it possible. Okay, so now we're going to talk a bit about Cantata. So this was a tool that the customer selected for actually doing the software verification. It's a very good tool. It's based on Eclipse IDE. You can develop your test cases in either the UI or the C code itself, and you can go back and forth. Uh, Basically, it creates a harness around a C module, and it creates a console application, which you could actually just go to a command line and run, and it'll actually run like all through your scenarios. You'll see the output on the console. It'll generate basic reports, and with some additional commands, you can also generate detailed HTML reports. We found that testers would initially use the GUI because it showed them visually where everything was. But once they got comfortable with that and they could see, what they were changing in the GUI, where it was going in the actual test code, which is just one large C file, they got comfortable just copy paste modifying, and that became a lot more time efficient. Okay, talking a bit more about tool setup. So in an ideal situation, the team lead figures everything out, writes perfect work instructions, and the team members just join. They go through some basic training, and they've got the work instructions. In reality, that doesn't really happen. And it has to be a trade-off between trying to onboard your team, do the day-to-day tasks, and also figure out the things that you need based on a priority. One of those things that we did eventually come to a point where we needed it critically was the ability to actually debug test cases. So this is a fairly simplistic screenshot here, but off to the right, you're actually looking at a debug session. So you've got the call stack in the upper left, you've got the variable window on the right and the upper right, and in the lower left, you've got the actual cursor position. So that highlighted green row or line rather, that's the actual line of code that's being executed. This is something that it's incredibly valuable to have. We did have instructions from Cantata on how to do this, but they didn't quite work. So we had to spend some time to actually refine them a bit to get it to work in our setup. And once we did, this was invaluable because we had test cases with very, very complex structures like pointers within pointers and so on. And those functions, they were behind the validation. So they already expected those pointers to be set up correctly. And if they were not, the code would crash. And without having a debugger to go in there and see where things were happening, we would not have been able to do those test cases. So the short version is we figured it out, we wrote it up on the wiki, customer was very happy with that, and our team members now had an invaluable tool for debugging very difficult code.
Yeah, thing to point out there as well is, we find a very good best practice is really getting these things set up at the start. We had a team of 11 on this project, but, test teams can be 20, 30 or more members. It's really invaluable to do this debugging when you have a smaller team at the beginning and write up good work instructions so that you don't have, 20 or 30 people all hitting the same issues all at the same time, which really bogs things down. So, that's kind of why we put this in the planning phase. It's really something you want to address up front and get those work instructions figured out. Because in our experience, documentation on the tools isn't necessarily up to date. It's not necessarily correct. And, it's better to figure that out earlier than later when you've got a lot of people who are, tied up because of that.
Yeah, like we did get formal training from QA Systems themselves, the company that produces Cantata. And during the training, I did make it a point to ask about how to debug a test case, and they actually provided us a technical note. So we made it a point to make sure we had that documentation from them. Another note too, just to touch on this code coverage point, our project did not require code coverage, but it was actually a very useful debugging tool. We would turn it on, we could run a test case, as you can see red, green, which paths were executed. And that was also very useful for debugging a test case where we may have thought it was going one way, but because of something elsewhere, maybe a global variable we didn't see, it went another way. So that's another useful debugging tool. Okay, just talking a bit about the IDE. So we did use Cantata for the test case development, although it was very hard on the eyes. It was a white only GUI. You can try to put Eclipse in dark mode, but it really doesn't look good. And we also needed a tool for day-to-day Git operations. So, creating branches, committing, pushing, pulling, things like that. We could have trained the team with the command line, but it was a lot easier to use Visual Studio Code, which is a completely free IDE. It's very fast and lightweight. It has a dark mode, which is like the screenshot on the right. And it has a built-in user interface for Git. So we basically went through the process, created instructions, lots of screenshots, and then it just became very easy for team members to do their day-to-day Git operations. And the other really nice thing about VS Code is that it supports extensions. So this makes it a very scalable tool. So the code we were testing was in C. So of course we used this C, C++ IntelliSense extension. That gave us things like mouse overs, drill down like control click and backwards, all of our definitions. So basically an indexer. Another very useful one is when we'd often pull down an existing code review, there was a spreadsheet. We were already in VS Code we just wanted to right click and open it, but the spreadsheets were Excel files, not text files. We found an extension called Open an External App. So we could right click, open, and then pick the tool we wanted, and we could open everything right from there. Git Lens is also another very useful extension, because this basically shows you all your Git history. You can even pick a specific file, show all the version history, see the diffs, see which user checked in which lines, which helps a lot if you're looking at something that may not look quite right. You can see who worked on it last, then you can go talk to them. And Hex Editor was also very useful, because there were some test cases that were very low level, working with binary data, and having a hex editor to actually see the bytes in the raw format was quite helpful. Okay, so this is just a very high level diagram, perhaps somewhat simplified, of the workflow that we used. I'm not going to go over the whole thing, but I just want to point out a few highlights. So if you look at the swim lanes, we've got the project engineer, which was our customer lead in London, England. We have reviewers, which were teams of 2 testers, and then we have the test developers. So the high level flow, starts in the upper left where it says start. So the lead would basically create test items, assign them. They would actually assign them all to me, and I would reassign them to my team members, going straight down to develop test. So a developer would develop the test, then create a review ticket, submit that for assignment. So drilling back up. In this project, the customer lead was required to assign the reviewers, but took input from me. So they would assign the reviewers. And then now we're in the middle swim lane on execute test. So basically the reviewers would have a meeting. They would use Outlook Calendar to block the time, and then Microsoft Teams. So one person would share their screen. They'd both have their audio on, and they would execute the test. So basically an independent pull from Git, make sure everything runs properly. That's very important to make sure you've got all the files configured. And then they would actually review the test. They would fill out a formal checklist. One thing that we found useful was it was a Word document checklist, but every time we did a review, including subsequent reviews, rather than overwriting or rather replacing the review date, we would actually add a new row. So we would say review 2 date, review 3 date, and that way we could see the chronological history, and actually helped us identify just how many review cycles an individual test was going through. So back to the review. Typically, there'd be a loop. So, reject quick comments, rework, submit for review. That would loop around, n number of times until finally it'd go all the way up to the top review, where the actual customer lead would perform, their review. There can also be a rework loop there as well. But finally, just kind of glossing over what's in the upper right, the MR stands for merge request, or in other words, in Azure DevOps, that was the pull request. So every tester would, have their own branch, and the pull request would get merged. So I'm just going to move on. All right, so now we're going to talk a bit about monitoring.
One thing I'd point out there too with the workflows, why we put that in planning is just for us for a very good best practice. When we start kind of test projects, typically, Sundeep and maybe the first few resources, they'll actually kind of go through this process. And even on this project, this isn't the original workflow. We try to identify if there's things that don't make sense, if there needs to be other states. So, the workflows are something to kind of think critically about, and maybe there's room for improvement. And it's something we, highly recommend you work with your vendors at the start to make sure that, once you start using all the tools, that the workflow actually makes sense and has all the steps necessary.
Yes. Okay, so now I'm going to talk a bit about monitoring. Okay, so some of the key metrics that we measured were the number of decision points and the number of modules. Basically, the decision points were the numerical decision points, and the modules were the actual C files. Each C file could have anywhere from 1 to over 200. In terms of scenarios, typically you would have, on the boundary, above and below, and then with some code reuse, you may have fewer test procedures as you dive into the code. Okay, so now I'll talk about key performance indicators. So basically, we knew we had about 120 modules, and there were about 5,000 decision points. So we assumed a few rework iterations, and we assigned modules one-to-one with testers. So initially, the progress was slow because we had to, get familiar with their code base, churn out the process, refine the process with the customer, and after that, things got smoother. The team got trained, the process got smoother, and random things did crop up near the end, but that was pretty much the progression of the project. So slow, then quicker, and then a little bit slow again.
Yeah, and to add to kind of the metrics and the KPIs in terms of how we pick them, the key thing with the metrics and KPIs that you want them to be useful towards the actual monitoring of the project and estimating. And what we mean by that is that, like, you want them to be granular enough that you're actually seeing progress on a daily or weekly level. And they should also be easily measurable. Like, you should pick metrics that you can directly extract or even automatically extract from the source work items. So it should be very easy if you get scope increases or if something changes to determine what the impact is. We think critically about that when we're determining these metrics, because these eventually become, and we'll get to this in the next few slides, what you're reporting on your dashboards. And also with the KPIs, it's something that you monitor throughout the project. You set them at the start, but things can change. So it's something that we work with our customers to always keep an eye on. Both, are we hitting the KPIs, or maybe the KPIs might need to be revised because of things that crop up during execution. But at the end of the day, they're a tool that you're using to monitor your progress and make sure you're hitting cost and schedule targets.
Indeed. Okay, so carrying on that discussion, we'll talk about dashboards. So Azure DevOps has built-in reporting capabilities that we found very useful. We created both burn down and burn up charts, as well as pie charts, and week ending Friday reports. We tracked both metrics in the previous slide, so the progression of decision points being closed out, as well as source modules being completed. So as Ryan mentioned on having important attributes, these source work items, that was a type of ticket, so to speak, in DevOps. So for every C module that needed to be tested, a source work item was created, and it had an attribute for the number of decision points. The customer filled them in initially, and we actually developed a regular expression with Notepad++ to recursively go through all the source files and actually identify the count of decision points. And also during development and review, the number of decision points was confirmed, because some things were not caught by the regex or not caught manually, but they were found later. And then that number, the attribute rather, in DevOps was updated, and that reflected immediately on the reporting.
Yeah, I guess just to add a bit to the reporting as well, like, the reports aren't just something that you're generating just to send up, to check status, but it's also, it's a tool that you're using to identify potential gaps. And we'll cover this a bit in the next slide. But to what I was saying before, with the metrics and KPIs being automatable and kind of measurable, especially for large teams or teams where you have people in multiple offices or multiple time zones, it very quickly becomes very time consuming to try to get manual updates from team members, and it's really not sustainable. So, a key thing with these dashboards and the metrics and the KPIs is setting it up so everything's done automatically. And that's really, really critical. And once you have that, it really lets you look at these reports more frequently and get good reports, on a weekly level. And these are really critical for us to hit schedule. It really is a tool that lets you see well in advance when something is becoming a roadblock or a bottleneck before it's too big of an issue.
Yeah, and it also becomes impractical to constantly be asking your team members what they're working on, and it also pesters them a little bit too much. So having a good workflow and good states lets you filter on those individual states, and you can actually identify, what your team members are actually working on. And so here's an example of a life cycle. So default lifecycle, proposed, active, closed. That's not bad, but we don't have as much visibility. So simply adding an additional state between active and closed, called resolved, now we can filter on that state. And I'll explain that bit in the next slide. Um, but sometimes the simplest thing is just refining your life cycle, adding a state here or there. So that way you have better visibility as to how the work is progressing.
Yeah, and I think particularly in the context of DO-178 testing, the default lifecycle of your configuration management tool probably doesn't assume it's a DALE program, right? Where there's multiple stakeholders and there's multiple layers of reviews, right? So it's very important to think about this in the context of the testing that we're doing in aerospace, and the lifecycle might be complicated. If you don't spend the time at the start to actually set that up in your configuration management tool to see all those states, it might say something's in review, and well, like, who's reviewing it, right? Is this you? Is it an end customer? And getting it set up at the start to have that visibility is really, really critical once you're going through the program to see where those bottlenecks are.
Exactly.
And this ties back in, right, to the workflow, right? Once you have that workflow worked through, it's very straightforward to look through that and think, okay, does our life cycle state and our configuration management tool actually line up with what we're doing on the project?
Yeah. So here's an example of a chart where we've highlighted tickets in their various states by the color in the bar. So the significance of adding that resolve state was to basically identify a bottleneck. So without going into too much detail, the BTR was the boundary test review item that the tester would create. So it would represent the life cycle of the review. So it would be separate from the source work item. And the process was that, you know, it would go in the active state. Two team members would have their meeting, they'd review it. Once they were done with it, it would need to be reviewed by the customer lead. We didn't have a resolve state. So initially it just sat in active. And we had a problem there because we couldn't distinguish, like, obviously it was assigned, but from a reporting view, we just had tickets sitting in active for quite a long period of time. Once we added the resolve state, we could immediately identify, okay, the ones in active, those are waiting on our reviewers. The ones in resolved, those are actually waiting on the customer to review. And then the customer could actually see, oh, wow, I've got all these tickets in resolved. I should spend some time to catch up. So that's an example of how we can leverage a good life cycle to identify, where we have bottlenecks. Similarly, another one too, even metrics, is a high number of reworks. So the blue bars, uh, that's always a red flag. If you have a lot of tickets in rework, something's probably going wrong, and that's a good indicator to dig a little deeper and see what's happening and see how you can improve on that. Okay, so now I'm going to talk about execution. All right, so in terms of onboarding, before the project even started, we actually got formal training from QA Systems on Cantata. That was critical because without that training, I don't think we would have been able to do very well on this project. And from that training, we got very familiar with the tool and how to use it properly for this project. So we had more team members on board after that training. And what we did, based on what we learned, we would put them through our own abbreviated version of that training with lots of exercises to make sure they got through that process. And then to also go through an example test case that the customer provided, which is part of their work instruction and training process. That way, every team member was not only proficient in Cantata, but they had also gone through the process of developing a complete test case against the customer software. What we also found very helpful is pairing new team members with experienced team members. That way, it became sort of an apprentice type of relationship. The new member could talk to the more experienced member because they would all go through the same process. They would all hit the same things. Like, for example, when they were hitting their stubs or going through a stub window, like, oh, if I click here, it's not changing here. the new experienced person or the experienced person would say, oh, that's because you have to look and click here. They would know that. They could do a screen share, show them. And in addition to that, we made a wiki, and we'll get into that a bit later.
Yeah, and I just add with this. So, the reason we got that training is Aversan's primarily VectorCast and LDRA and RTRT is the main tools. But we found with this training onboarding, getting the training ahead of time, it really didn't have that much of an impact. For our testers who knew, VectorCast or something like that ahead of time, within a week or two, they're pretty productive. So we found this very, very useful and practical in this project.
Yeah, and the testers actually liked this tool a lot because they could actually write their tests in code, and that made it more of a development-like experience rather than just using the GUI for everything. I liked it for that reason too. Okay, so now we'll talk a bit about quality. So consistency is the key, because when you have a team of multiple people, without good guidelines, everybody will do things a little bit differently. And that's not ideal when you want to create a very polished looking work product. So what we did, the customer had work instructions. We worked with them to further refine them and create a technical wiki on Azure DevOps. So to create testing guidelines, review guidelines, as well as technical instructions. These documents are very important because testers needed to know, okay, how should I be writing my test cases? Should I be little things like, should I be spelling out words or should I be writing numbers? Should I number things this way or number things that way? How should I break things down? The testing guidelines covered all that. And then when it came to the review, like it needed to be a fair process. If the reviewers just used arbitrary criteria, they would always be, at ends with the testers. So we created review guidelines saying, we walk through basically all the components. So we had the spreadsheet, which was the test cases, and also the test procedures, which was the cantata code. And we covered everything that the reviewer should be looking for. We published that wiki page. We went through it with the team. So that way, both the testers and the reviewers knew what was expected of them when their test case would go to review. And we worked with the team because, no instructions are perfect, but having a wiki on DevOps made it a very agile process. We could simply identify the issues, have some discussions, figure out, how we wanted to change things, update the wiki page, just send it an email or a message on the chat and say, so-and-so has been updated, here's the link. And it was that easy.
Yeah, I'd say particularly in the context of higher DAO level programs, quality is critically important. Even on this program, the first layer of review for us was the project engineer, but there was reviews from their end customer, and eventually there's SOI audits, FAA reviews, right? So there's bigger and costlier rework cycles even outside of that workflow. So we can't really stress enough how critical this is, and we find this process works very, very well. And on this project, actually, when there was the first review from the end customer, one of the big US defense primes, we passed with only like minimal findings, which got us a pretty big commendation from both the prime and the customer, which I think is a testament to how well this kind of process works that we've set up. And, we highly recommend anyone use a kind of similar process for your own projects to maintain quality.
Indeed. Okay, so now we'll talk a bit about automation. So automation is very important for time-consuming tasks, and we're going to go through some examples. So with this project, the customer required certain documents, such as a summary report, configuration index. We knew all the data was in the test artifacts, so a combination of the spreadsheets and perhaps even the test cases themselves. So initially the thought was, okay, one-time effort, somebody manually go through hundreds of files, pull the data we need, and generate the reports. We didn't want to do that. So we proposed that we automate this using a script. So we wrote a Python script, used a library. There's many out there for parsing spreadsheets, and basically extracted all the data we needed and it actually generated the reports in spreadsheet format with the correct sheets and columns and so on and so forth. It actually only took about a minute or two to run, and this was very useful because we actually had to rerun this several times because some test cases had to go back and be updated. Another thing that this also provided was some of the spreadsheets were missing certain columns and sheets because those were added to our process later. We had thought we'd gotten back and fixed them all, but of course some were missed. So this tool actually identified them, and then we had a far greater level of consistency. Okay, another point of automation was running a full regression. So basically all the test cases need to be rerun and fresh reports need to be generated. So this could have been done manually. Within the Cantata GUI, you can run, one test case at a time, which would have been slow because we had over 100 of them. But Cantata test cases can also be run from command line. So we developed a script to basically recursively go through, find all the test cases, run them serially, and also run an additional command to generate a detailed HTML report for each one, which was something that the customer required as an artifact for audit compliance. This script, we chose to make it a Windows batch file. It made the scripting a little more challenging, but it allowed the script to run on any computer, so it had no dependencies such as Python. We also made the script parse the log file and produce just a simple, we made an additional script rather to parse the text log file and to generate a spreadsheet summary. So that way we could actually quickly see, how many test cases we had and the pass and fail counts. Okay, so we'll talk a bit about test artifacts. So with any DO-178 project, you need to make sure you have the correct artifacts within configuration management. So in this project, the test cases were the spreadsheets and the test procedures were the Cantata projects. So we had to go through the Cantata documentation and make sure that we were checking in all the necessary files, which it was a bit of an effort itself because Cantata does generate a lot of project files. Some of them are auto-generated and some of them are not. So we went through that, figured it out, and also, the best way to actually verify your work is to pull it out of configuration management to a clean directory, build it, run it, open it up in the IDE, make sure everything works correctly. And if it doesn't, you do a diff and you keep doing that until you finally get all the correct files in place. And then you document it. So in terms of software release analysis, the customer actually did have an additional software baseline, and they did not think it was that much effort, but they asked us to do an analysis to be sure. It was an independent check. So we used a few tools of note, mainly because they were free. So we used KDiff3. There's a screenshot on the right there for diffing, so side by sides. We used Notepad++ to run regular expressions to identify the updated count of decision points and then diff them. And we also did a combination of manual analysis as well. And based on all that, we were able to provide an estimate very quickly to the customer. And unfortunately for them, our analysis showed that they actually had a considerable amount of rework. But in the end, they were glad that we actually caught that in such a short amount of time.
Yep, catching it quickly was helpful.
Indeed.
And it's always safe to assume, even if they don't think there will be another baseline, there probably will be.
Or it could be more work than they think it was. Okay, so
Yeah,
go ahead, Ryan.
Yeah, so I can go through. So we'll just to summarize, right? So we kind of covered challenges in planning, monitoring, execution. So I'll just quickly recap. So in the planning phase, right, what we covered is really selecting the right tools, especially in the context of remote and distributed teams. This is important to pick tools that support that kind of working structure. So We found cloud-based tools work very well, and virtual machines especially has been really instrumental to making this a pretty seamless process for ourselves and our customers. And further selecting tools that automate reporting. And lastly, just picking free ones. It seems like a small thing, but it actually made it a lot easier for our customers to set up these VMs because they didn't have to go through their formal IT for licenses because we used free tools. So it just made things much easier on their end in terms of the licensing. So if we needed to add another team member, we didn't have to wait 2 or 3 weeks for them to get, an MS Office license or whatever it was. And then estimating projects KPIs, of course, work with your vendors and your team leads to make sure that the KPIs are meaningful, they're measurable, and importantly, they support automated reporting out of your tools. And then lastly is the workflows, which typically you probably have a workflow before you're going into a project, but it's always best to work through that with your team leads and, any vendors you might be using, and take the time at the start in your planning phase before you're diving into to make any adjustments on that might make sense. For monitoring reporting, use the tools. So building automated dashboards, we find extremely helpful. We had weekly meetings with the customer. We were actively looking at those reports, and, we weren't just generating them to say we're on time or we're not on time. It was using it as a tool to identify bottlenecks and take corrective action, which goes into the artifact lifecycle. We set that lifecycle up purposefully to support using this. And on this project, it was helpful. We were able to execute on time, in part because we could identify slowdowns almost immediately in that weekly session. You could see, okay, this part of it's growing. How do we take corrective action? And that goes again to reporting often, which is easy to do when you have these tools set up automatically. When it's not a lot of effort to build that report, it's easier to do it more frequently and, spend more time taking corrective action and less time, building reports or getting status updates from team members. Ideally, it should all be automated. You shouldn't really need to go to team members at all unless, there's some issue or, maybe they need some help. And then on execution, having a solid training and onboarding process we find critical, and we document it as well, right? So if you have teams in other offices or, other time zones, people that are really remote, having that training and onboarding process documented, really, really helps a lot. Then on productivity, we're always looking for ways to automate. This is really critical. So, just for us, how we think about it is it's good to take a step back and just look at tasks that are either particularly time consuming, things that are repeated very frequently, or things that have a high chance of human error. Those are the big ones for us that we look at. And if you can, throughout the project, just take the time to look at those and see if there's some tasks that maybe are open to building some automation tools, to support your project. And then, of course, automated regressions are key, and especially building automated regression reports. It's helpful to come in on a Monday and get an automated regression report that tells you, which tests passed or failed. And for maintaining quality, we can't stress this enough. We find our best practices really developing that knowledge base, ensuring the testers are referencing it throughout the project, and keeping it up to date as well. And then lastly, managing the artifacts, which of course is especially important in DO-178 for traceability and auditability. And with that, I think we'll go over to Q&A.
Yes, hi. I've magically appeared again. Thank you so much, Ryan, Sandeep. It's a really interesting area, and I personally really impressed by the level of planning and detail and in the workflow and the monitoring. I think it's as ever the sort of devil's in the detail, I guess, especially with something as complex as this. If you have any questions, if there's any more questions from the audience, now is the time to ask them. We've got about 15 minutes. I do have one from the audience. Just before we get to that one, I'd just like to ask a few that I've jotted down here quickly. We kept talking about different, working across different time zones, and you had some great suggestions for that. Is there anything else? Any other kind of, when you've got a team that could be working on different continents, it's often an issue. Are there any other kind of practical tips that you've got for managing that or helping out with that?
Yeah, I think that the key one for us is really that knowledge body, right? Like that by ensuring that the teams in separate offices or time zones are referring to the same central guidelines, it lets you make sure everyone's working to the same standards and the same expectations, right? And you can keep that up to date, without having to, get on a midnight call with the team somewhere else, right? And it just makes it very easy and very streamlined to make sure everyone's working to the same level that you want them to be working at.
Okay, great. So I think you have something there?
Yeah, I just wanted to add to that. One more thing to take into consideration is that when you do have distributed teams, like the dominant language is English, but when you cross different continents, the interpretation of certain things can be a little bit different. So when you are writing your documentation, you need to be wary of that and make sure that you try to word it in such a way that it is um, neutral enough so that all English audiences can understand it properly, and also just check with them from time to time too to make sure that it is clear enough and not using like some slang or something that they may not actually understand.
Sure, yeah. And just another quick one from me. I mean, obviously, we're talking here about DO-178 testing. Do you have any suggestions? I mean, could you apply these kind of things to these practices to stuff with a lower criticality, with a sort of lower design assurance level? Or is it kind of a shared thing?
Yeah. I mean, at lower criticality levels, you likely don't have as complicated of a workflow, but these are really general best practices, and we apply these in any industry that we're working in. Aversan, Dowlais, aerospace is kind of the top, but we take these lessons learned across all the software development that we do, really, just regardless of the Dow level. So, you might not have quite as strict of a review process, but any project that you're doing, software quality is important. You want to be building a good product that's reliable, and these best practices will help you in any project, I think.
Yeah, and we've seen projects that don't have to even formally follow this process, but they choose to follow the process anyways.
Okay, right, great. And also, Sandeep, I think you mentioned this during your slide with the graph, the line graph and the bar charts about rework. I mean, with tests going, if a test is going back into rework too many times, I mean, how I think you flagged it as a big problem. I mean, how can you give me a bit more detail on how you might deal with that?
Yeah, it usually starts by looking at the review comments, having a clear perspective, like looking at them and saying, or going through them individually and assessing, are these comments reasonable? And then looking at the review guidelines, making sure the guidelines are actually clear. And from that, you need to more or less assess, whether the tester, needs a bit more training, or whether the reviewers need a bit more clarification, or maybe a combination of the two. Sometimes it could even be that the overall work instructions were ambiguous. I can give you an example actually where we needed to test a certain condition. It was something that we actually missed writing down in the work instructions. So some of the testers were checking it, some of the testers were not. And there was a bit of a struggle going on because the reviewers were saying, oh, you should not be testing this. The testers were saying, oh, no, we should be testing this. So we had to, once we knew that was happening, because we started seeing an uptick in rework for the same issue, we had a quick meeting with the customer to confirm that, how they wanted it to be done. We updated the work instructions. We had a meeting. We informed the team, okay, this is how it should be done. Sorry guys, we missed that. We need to go back and fix these test cases, and it should be all clear now. So that's how we do it.
Great. Okay, thanks. I got some good questions here from the audience. So, and I can see the one here from Ina who's having a bit of a complaint about the number of emails that we send her. I will raise that with the marketing department. I get all of those emails as well, Ina, don't worry. But I don't think now's the time. I don't think the guys here will have much to say on that. So I'll go straight to Martin Hawley's questions. He wants to ask about the target hardware. He's assuming that this type of software testing isn't running on the target hardware. But if it is, I mean, how if it did, how did you manage that in the cloud environment? What's that relationship with the hardware?
Okay, so in most projects, especially with embedded testing, you are able to actually cross-compile the code. So what we did is we actually executed all the tests against the Windows environment. So using the GCC compiler, and it would compile it for Win32. So we're actually able to execute the tests on the Windows virtual machines themselves. But not obviously, or not obvious, but it was not the actual target environment. So what the customer would actually do is they would recompile the test cases for the target processor, and as part of their verification, they would actually run them on the target environment and make sure they worked correctly. Uh, that is fairly typical because oftentimes the target hardware is very limited. Like you may have one or two if you're lucky,
Mm,
and the access is somewhat restricted because you can't give everyone VPN access to a lab environment, and it has to be very controlled.
mm,
So that's an example of how we did it on this project.
Yeah, and on other projects as well, often we'll build like a layer, like a batch executor on top of the target. So on other projects that we've run, all the testers would actually publish their tests up to this, the batch execution environment, and then they would actually manage running the tests on the target. So testers submit all their tests to be run. This other piece of software manages the on-target testing. And when the testers come in the morning, it gives them their reports back. And once you have that set up, that test target hardware can be anywhere, right? So that's another way of managing it.
Okay, great. And Martin's second question, he wants to know, did your work include preparing or even discussing with the authorities on WRT certification? If so, do you have any tips on that as well?
So I don't know if you want to speak to this, Sandeep. On this project, our customer owned majority of the certification liaising, but I don't know if you can speak more to this, Sandeep.
Yeah, I was going to say the same thing. On this project, they dealt directly with the certificate authorities. We have done other projects like DAL-A level testing where we actually did interact directly with the authorities. And that was basically just assigning a lead to work with them, go through the audit comments, bring them back to the technical lead, identify, what things we need to go back and correct. A lot of times it was just clarifications, questions. The severe findings were the ones to be more wary of. For example, lacking a trace or missing a critical piece of documentation, or documentation missing an important section, things like that. Basically, it's an iterative cycle. You need to work with the auditor, resolve the findings, and just get through the process.
Sure. Okay. Thanks, Sandeep. Moving on to this question here from Andre Chews. Andre wants to know if you ever use data analysis tools like KNIME.
No, I'm not familiar with that tool.
No. Okay, great. And then there's one here from Mohammed Ali Asgar. He wants to know if those test units for individual modules or integration tests involve multiple modules. Were those test units for individual modules or integration tests involving multiple modules? I guess, yeah. Does that make sense to you, Sandeep?
Yeah, so on this project, they were unit tests. So they were basically individual modules in isolation. We have done work on another project where we did also do integration testing. So we had modules communicating or interfacing with each other. So that would verify things like control coupling. And then the level above that would be hardware software integration. So actually running tests on the live target with the complete software load. So that would be called hardware software integration. The integrated we normally call software integration. And then for this project, this was unit testing. And even more specifically, it just focused on the boundary value aspect of it.
Okay, cool. Thank you. So we have about 5 minutes left. I've got 2 more questions just submitted. If anyone has any questions, anything that they want to ask, now's the time to do it. So this one here is from Philippe I don't know if anyone can do any better with that surname than me. It's a little bit tricky. I'll just ask the question. Was the test hardware distributed locally? What he means is did the hardware have to communicate via the cloud or just directed Ethernet connections? Did you have to generate any ICDs for communication? So, yeah, anyone with Sandeep?
Yeah. So again, this was unit testing, so everything was tested in isolation, and we ran the test on our own virtual machines compiled for Windows, and the customer actually ran them on the actual target hardware. So that's how we took care of that.
Okay, great. And this last one here from Mohammed Akib Cow. He wants to know, how efficient is it to develop regression, automation, and reporting in MATLAB instead of Python?
Take your pick. Python is a tool that I was familiar with and very quick for writing scripts. If you're more proficient in MATLAB and the customer has no issues with installing a MATLAB runtime as for a dependency, that can be a perfectly viable solution. It's just to each their own. Pick the scripting language that works for you and works for your customer's environment.
Great. Okay. All right. So if there's no more questions, I'll just wrap up. Really, I don't know whether or not you guys want to flick back to your contact details. Maybe was it right at the start? It might be a bit just for people there. There you go. Great. So Sandeep and Brian can be contacted that way. This presentation, including any of the materials that go with it, will be available. You'll get a link afterwards to the platform, and then the story will be updated on the Aerospace Testing International website also. Yeah, all that remains for me to do is to thank Sandeep and Ryan for their time today, their presentation. Thank you very much, and thank you, the audience, for your attention and participation today. I appreciate it. Yeah, everyone, have a great and enjoy the rest of your day. Thanks.
Thank you.
Thank you, everyone.